So this is the part 2 of typed array series. In this part, as I mentioned, like we are going to code the theory you have discussed in the part 1. If you have not seen the part 1, then I'll put the link in the description so that you can see the theory first. Okay, let's get into coding. So let's create a buffer first, and the buffer is a array buffer. So just create a array buffer by calling array buffer, and then here we'll mention the size, how many bytes we want to give in. So suppose the byte size is 16. You can put any number you want, any byte size you want to give. So let's check first that the size we have given it's correct or not. So how to check that? Let's go for buffer dot byte length. Yeah, and if that is equal to 16, then we'll print like, okay, so like console dot log that it's correct. It's 16 byte. And if that is not true, then in the else part we can say, oops, console.log, and maybe it's wrong size. Okay, let's save it, go for terminal and type node dot typed array. I'm not sure what's happening here. Okay, so node typed array dots there. Okay, so it's giving us it's 16 bytes, so the byte length is correct. Okay, let's comment this out. This is no longer needed. Then next we can initiate a view, as we discussed in the previous video, that to access a array buffer you have to, like any if you want to perform any mechanism onto that array buffer, you have to create a data view. So to do that, suppose I will initiate my typed array, and suppose it is a integer of 32-bit. Okay, then I will call this buffer inside it. So what basically happens is we are initiating a typed array of 32-bit integer type, and I'm using that buffer memory. So now suppose I will just console log it. So let's see that what we just created. Okay, so the typed array here. So the memory we allocated is 16 bytes, so that is actually 128 bit, 16 into 8. So in 128 bit we can afford like 4 elements, like 32 bit each. So now it is not initialized, so everything is 0. So suppose I will allocate that integer on the typed array, and suppose the at index 1 the value I am saving is suppose 4. Let's see. Okay, so the at index 1 of integer 32 will have 4, so seems correct. Okay, I mentioned in the video that we cannot perform any push pop operation into typed array. So let's see that is working or not. Maybe the typed array dot push. Suppose I'll push the value 5. So this thing should not work and it should throw some error. Yeah, so it is giving me like type dot array dot push is not going to work. This is not acceptable. Okay, so basically we can now suppose we want to do a push operation. So how to do that? In the video I mentioned like where we can use a spread operator to convert this typed array into a normal array. So suppose I will create a normal array equal to a spread inside a bracket, a spread operator to then typed array. Okay, so let's console log that also. I don't need this typed array anymore. I can just put the normal array. So yeah, it's working fine, but that is not we needed, right? We needed to check this push operation is working or not. So for this normal array we can push a value 5 or 6, anything. So we want to see this one is working or not. Yeah, see, the push operation is working. So whenever you are done with your typed array mechanism, I want to get a normal array out of it, just use the spread operator. This is more convenient. Else we can do that same thing with array from also. So let's try that. Let's comment this part out, and this part I am going to write array dot from the typed array. Okay, let's see this is working or not. Yeah, this is working also fine. Okay, let's comment it out. I'm leaving this all commented out and I'll put that into GitHub so you guys can check it out. I mean, you can do any experiments you can, or in the process you can learn. Okay, so for next, suppose I also mention like for the same buffer we can allocate a multiple view of it. So for that, suppose I need like the first two bytes suppose from 0 and 1, then I will go with not 0 and 1. Suppose let's go with the same buffer whole and another view. Suppose check this as array 6. This is 32-bit view, right? So this is a 32-bit view and we'll create another, and let's name it as 16-bit. So 16-bit view will be like new integer the same, like 16 array from buffer. Okay. So it's a new view that will contain each element of that typed array as 16-bit. So how many is going to be afforded in this 16 byte? So the answer will be like 8 element. So suppose I will put like the typed array of 16-bit and the element, so the 0th element will be suppose 3, and now we can like print this typed array. So what is going to be printed? Let's see it for sure. So obviously, as I mentioned, like it is a 128-bit memory and you are allocating 16-bit each. So there are going to be 8 elements. But the first element is going, the first bit is allocated as 3 in this view. But this 4 is being allocated in the previous view. So the entire memory you are accessing can be written as this. Getting the point? Yeah. So next, we are going to like create so let's print that another type data also. That will clear some concept. So if I will print that array again, it will give us the view of that buffer in the terms of 32-bit elements. Okay, so the first element already allocated by the second view is 3, and the next part is the next 32-bit, the 4 is been stored. Okay, so if you remember from the previous video that that image where I have mapped a memory, in that we can refer what I'm talking about here. Okay, next let's work with the complex data structures. I mentioned about a complex data structure of C, that is a structure. It will hold like this part. Let's just copy this thing and print it here. So a structure of that will have a value of long data type, then character array, then a float, and we are going to imitate all this functionality as a JavaScript typed array. So for that, suppose I will create a new buffer. Let's comment this console logs. It will affecting our output. Yeah, there is no console logs. So we'll create another buffer. Suppose buffer 1, and this will have a new array buffer of suppose size 24 byte. Then to imitate that, so I will have a ID view, and I will have a username view, I will have a amount due view. For every variable I will have a different view, because they are of different types. So like constant ID view. Okay, so for ID view this will take like on unassigned integer, so that will be uint 32 array, and that will have buffer 1, but I will allocate from 0 to 1 index. Okay. So next we are going to create a view for the username, so that will be const username view, and that will be like suppose a unassigned of 8-bit integer, so that will be int 8 array from buffer that is buffer 1, and then from 4th to 16th. Okay. So next I will have like const amount due view, that will be suppose new, and this is a float array, so float 32-bit array, and from buffer 1. Now you will get a hang of it how to declare all those. So from 20th to 1. Okay, so this is how I'm going to like create new view for this same buffer. So let's print all this. suppose const id, not const, console log id view, then username view, then amount view. So let's print that. Oh, did I did something wrong? Okay, so I'm not inside creating it properly. Now it is correct. Yeah, cool. So we have like the one value in id view, then username view will be like 16 values, and the float array is going to be one value. Okay, but it will start with the 0th index, it will go to the 4th index, it will go to the 20th index. So we can allocate same the values to every types, and okay, that's it. So this is all for the typed array, and maybe in the next video we are going to discuss about how this base 16 encoding strings is going to work. Or there are many topics on typed array. There are faster canvas pixel manipulation with typed arrays, and their binary data in the how they are the binary data in the browser, how the Indianness is going to work. There are many topics. So maybe we may cover, if I cover, I'll put that in the same series. So if you like this video, put say thumbs up, and if you want to like support me, there are description below, and you can, I'll put videos every week for more core concept on JavaScript or Python. So I'm just getting started. Yeah, thanks guys.